Hi everyone. In this video, I'm going to discuss two questions um, from the SAT practice test 1, section 3, the section that is without calculators. Right? Okay, so these two questions, one is both are actually related to geometry and trigonometry, so they are in the same line. So that's why I thought I should discuss these two questions in a single video. Okay. So the first question, so this is the 17th question in the third section, in that practice test. So you have, so a summer camp counselor wants to find a length x. Okay, they have marked this length x, which is AB, across a lake as represented in the sketch above. The lengths represented by AB, EB, BD, and CD on the sketch are determined to be 100, 1800, 1400, 700, and 800 respectively. Okay, so the first thing that when you see something like this, a geometry word problem, the first thing that you should do is, okay, you have a diagram. If they are given a diagram, you can use that, or if they haven't, based on the details, you can draw out your own diagram and then just label all the data on the diagram itself. So it says that AB is supposed to be 1800. So I have 1800 over here, and then EB, so AB is 1800, that we have already taken care of. Okay, EB is supposed to be 1400, so we do have this 1400 over here, and then BD is supposed to have 700 feet. So BD over here is this 700, and then CD is supposed to have 800. Okay, so we have these lengths labeled on the diagram, and so it's not that we don't know anything about BC. Okay, so but let's move on. So segments AC and DE intersect. Okay, so it's already shown in the diagram, this part of the sentence, the problem, and that's redundant in the sense, so you don't need to worry about that much. And then we have this angle AEB. So this is the angle AEB, which is this angle here. Let me mark it in a different color. This angle over here, and CDB. So this angle over here, they have the same measure. So the angles, the size of these two angles are the same, right? Okay, so you have this diagram, and then you are supposed to find x here, right? So when you have some diagram like this where you have two angles equal, it's very possible that what you're looking for is similar triangles, right? So similar triangles help you actually find unknown lengths of a triangle, right? So in this case, the unknown length that we are supposed to find is x, this one, which is the length of AB. I mean CB is not, the length of AE, but CB, BC or CB, whatever you call it, is also unknown, but we don't need to worry about that. They haven't asked anything about that, right? So let's move on. So you see that there's two red angles equal, but then we need actually all the three angles be equal correspondingly in the two triangles. Okay, so one thing you notice that is that in these triangles you have these vertical pairs of angles, right? This one and this one. So those two angles are also equal because they are vertical pairs. Let me write here, these are like vertical pairs. So you know that vertical pairs of angles are equal, right? So sometimes some people call this vertically opposite pair, vertical pair. Anyway, whatever you call it, these two angles will be. Okay, so what about the third angle? So you can think about this. I won't explain too deep into this, but this is something that you can understand, right? So you know that the interior angles of a triangle add up to 180, right? So if you have two pairs of angles equal in these two triangles, the remaining pair of angles should be equal, right? Because all these angles add up to 180. So it's the idea that you know that with that idea you know that this angle and this angle should be equal as. Okay, so you know that these three pairs of angles are equal in these triangles. So let's write down the similar triangle. Let's set up the similar triangles. Okay, so similar triangles, right? So I'll first pick the larger triangle, which is AEB. So I write AEB, the triangle AEB. So the order of these letters that I write is also important in a sense. I mean, when you write the two triangles. So for example, um, so A is equal to C in the other triangle, right? So I will just start writing C, and then E is equal to D in the other triangle. So I'll write CD. So corresponding A is C, A is equal to C. So A is equal to C and E is equal to D, and then B will be equal to B in this triangle itself. So yes, so this is how these triangles are matched, does match each other, right? So I mean, this is not anything standard or something, but writing it in this sense really helps when you are doing the when you are working out the problem. You will see why. Okay, so okay, let's do this. So we have wrote down the similar triangles here. Now it's for us to work out the side lengths. Okay, so look at AEB. So you have AE, so that's a side. AE is a side. So the first two letters form a side. Okay, AE. Now let's go on to the other triangle. The first two letters form a side, CD, right? So this is the CD side. I divide AE by CD. So you see why the order of these letters matter, right? I mean, it matters when you are writing things out in this form as fractions of sides, right? Okay, so we are done with the first pair of sides, and let's move on to the next two letters. So the next two letters on the triangle AEB will be EB. So you have this, and the the second two letters would be DB in the other one, right? So we write EB and DB. So on the top of each of these fractions, you have AEB sides, and on the bottom you have the CDB sides. Equals. Now we need to consider the third side of these triangles. So what I would do is, so I'll go around BA. So I will pick BA, and over here I will go around and then I pick BC. Okay, so it's not that hard, right? So if you write this in the correct order with the corresponding angles, with the corresponding angles in the correct order, it's just a matter of picking out two letters each time and writing out these fractions, right? Okay, so we have done this part of the question. Now we need to actually do the actual math, working out what x is. Okay, so let's see. So AE, do we know AE? No, we don't know AE, but that we call is x. Okay, x. So what is CD? That's going to be 800. And what is EB? EB is 1400. I'm referring to the triangle that we labeled the side lengths, right? Okay, and then you have DB. DB is supposed to be 700. Okay, that's fine, we know this. And equals BA. What is BA? That's supposed to be 1800. And BC, so what's BC? Okay, BC is unknown, and I don't think we need BC to solve this problem anyway. So now what we do is, we want to find x, right? At the end of the day, we need to find x. So look at these three proportions, right? So 1 contains x, this contains x, okay, that's fine. This contains both the numerator and the denominator is known, right? So that's a good thing. So we know this proportion in it. we totally know this proportion what this 10 goes to. But this proportion over here, the BC is mysterious. We don't know what BC is. So we can just ignore it for the moment. We'll pick the proportion that contains X because that's what we need to figure out, and the completely non-proportion, which is this, right? So we want to pick that up, 1400 over 7. Okay, fine. So 1400 over 700 is equal to 2, right? So dividing 1400 by 700 is just 2. Okay, so what do we have? X over 800 is equal to 2, right? Because 1400 over 700 is just 2. Okay, so you multiply both sides by 800. So let me just multiply by 800 on both sides. You get X equals 1600. So this should be answer, 1600 feet. So you work out this problem. Don't forget to write out the units feet. So probably this is a written question. This may contain some points in itself, right? So don't forget the feet. Okay, right. So we found X. So the next part, I'm going to do a little bit more on this problem, which is actually not needed in the question in your exam, in the practice test at least. But for you to work out, right? For you to learn. Let's see if we can find BC. BC is also unknown here, right? So in case you want to know, in case you are curious about BC, we can work that out too, right? So what do we pick? So we have 1400 over 700, which is a completely known figure, and the figure that contains BC. So we need to find BC. So I'll just write 1800 over BC, right? BC is, you can write it first over there, and that is supposed to equal to 1400 over 700, which is equal to 2 again, right? Okay. Now we just find out BC. So I'll just multiply both sides by BC, and I get 1800 equals 2 times BC. Okay, now what? Divide both sides by 2, right? So BC is going to be equal to 1800 over 2, which is just 900. Okay, so 900. So that is just if you want to know what BC is. So this is a good way. We are learning this, so you can just work that out also as an exercise. But in the exam, you just need to work out X, and this is just all. You don't need to find BC. So BC is just kind of a redundant piece of data. Yeah. Okay. So I think this would have helped you understand this question much better, and 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 I hope this help you understand more about similar triangles too in general. Okay. All right. Let's move on to the next question that I have prepared for today. So this is trigonometric question. So in a right angle triangle, one angle measures x, where sine x is equal to 4 over 5. What is cosine 90 minus x? Okay, so we have this. Let me draw a right angle triangle. Let's see if I can do this. So let's just draw this like this, and let's draw the hypotenuse. But let me just finish this off. Wasn't perfectly drawn, but yeah. So this is our triangle, and let's say x is this, x angle is this, and this is a right triangle, which means this should be 90 here, right? So that's 90 degrees. And by the basic geometric rules on a triangle, that if this is x in a right triangle, the other remaining angle should be 90 minus x. Okay, so this is actually going to be 90 minus x. So the angle that they are referring is this. Okay, fine. Let's now recall. Okay, let me mark these numbers. Well, let's see. So based on what we know that, so we know that sine x is opposite over hypotenuse, right? So opposite to this angle x. So this is the hypotenuse. Whatever you do, hypotenuse won't change. But depending on whether you're looking at this angle x or the angle 90 minus x, the opposite and the adjacent changes. So the opposite angle to x is going to be this. So this is going to be the opposite to x, this is, right? And this is what you have. So you know that sine x is 4 over 5. So the hypotenuse is going to be 5 and the opposite angle, opposite side is going to be 4. Good. Okay. Right. Now they want us to find cosine of 90 minus x. Okay. Cosine of 90 minus x. Okay. So that comes from the adjacent over hypotenuse. So remember that this adjacent is not something's fixed, it's relative to the angle. Okay, so you see that this 90 minus x angle and the adjacent angle to it is exactly this. So this is equal to the adjacent to 90 minus x. Okay, so we write it like this. Right, so this is the adjacent to 90 minus x. Okay, so this formula is adjacent over hypotenuse. So we have adjacent here, which is 4, and again 5. So the hypotenuse won't change, it will be just 5. Okay, so 90 minus x, cosine of 90 minus x is going to be 4 over 5. The same thing as sine x. So you see that sine x value is the same as cosine of 90 minus x. Alright, so was this a coincidence? Was this a coincidence? No, I should say. This is in general. So what I mean is that sine of x is equal to cosine of 90 minus x. Always. This is always going to be true. And the other way is also true. Cosine of x is going to be equal to sine of 90 minus x. So these are true. So the reason is that, so this is so this side is basically going to be adjacent to x, but also equal to the opposite of 90 minus x. So you see that this side is directly facing not the 90 minus x angle. So that's why this is opposite. And now if you can just work out the Pythagoras theorem. So let's say this is h here. If you just work out the Pythagoras formula, so that should be 5 squared equals h squared plus 4 squared, right? So this is 25 equals h squared plus 16. So h squared is going to be equal to 9 and h is going to be 3. So this is supposed to be 3, right? So and then you see that you can do the same trick with what we did earlier. So let's say you have cosine of x would be basically adjacent over hypotenuse, and the adjacent to cosine x, as you can see, is going to be 3 over 5. The hypotenuse is 5 anyway. So now if we just want to see sine of 90 minus x, that's going to be the opposite over the hypotenuse. And what is opposite to 90 minus x is 3. And the hypotenuse is always 5. So that's how you get this. So, right. I mean, in general, for any number, I mean, it need not be this triangle, any right triangle, you will be able to see this, right? So all this thing that I worked out after finding cosine 90 minus x is not directly involved to the question, but I wanted to discuss this so that you get an understanding of how this works, right? So remember that these two formulas are really helpful, right? So if you knew this, you didn't have need to draw all these triangles in this exam. You just would have just wrote out 4 to 5. No harm, right? So things, these are some easy facts that you can also remember, but also try to understand why this is true. Okay. Right. I think this video helped you understand some important concepts in on similar triangles, which is a pure geometric subject, and then also on the trigonometric concepts that we talked today. Right? Okay, so see you in another video, and hope you have a nice day. Bye.